This video explains the tests conducted as per IS 210-2009 for grey cast iron, an Indian standard developed by the Pig Iron and Cast Iron Sectional Committee under the Metallurgical Engineering Department at BIS. Before performing the tests, please make sure you comply with the safety practices in your lab and also the ones required for the tests specified in this video. Let's dive into something fascinating that's all around us but often gets overlooked. Grey cast iron. Ever wonder why car engines, machine parts and even heavy tools work so well? Well, a lot of it has to do with this amazing material. So, what is grey cast iron? Basically, it's a type of iron that's widely used in industries for its unique properties. And to make sure it's up to standard, we have something called IS 210, an Indian standard that checks if grey cast iron is just right for the job. This standard ensures it has the right mix of elements, the correct microstructure, the needed strength, and free from porosity. Grades as per IS 210. IS 210 specifies 7 grades designated as FGXXX, where FG represents grey iron and XXX indicates the minimum tensile strength of that grade in MPa. For example, FG 150 refers to grey cast iron with a minimum tensile strength of 150 MPa. Let's dive into some interesting facts and questions about the product you have just learned. First up, here's an easy one. Which Indian standard is available for the grey cast iron? That is IS 210. Now, let's get a little more specific. What does 400 in the grade FG 400 represent for grey cast iron? It represents the minimum tensile strength for the grade FG 400 should be 400 megapascal. Chemical composition analysis of grey cast iron is crucial for ensuring the material's mechanical properties and performance. For example, carbon and silicon contribute to graphite flake formation, improving vibration damping and machinability. Accurate analysis helps meet quality standards and application requirements. The composition of cast iron is generally at the discretion of the manufacturer. However, the purchaser may specify maximum limits for phosphorus and/or sulfur depending on application requirements. Phosphorus analysis is conducted using the alkalimetric method as described in IS 12308 Part 5. The process begins with accurately weighing the metal sample and dissolving it in nitric acid to create a clear solution. This solution is then filtered to remove any undissolved particles, ensuring a purified sample for analysis. Impurities are eliminated using potassium permanganate with sodium nitrite added to neutralize excess oxidants. Phosphorus is precipitated as ammonium phosphomolybdate by introducing ammonium molybdate into the solution, isolating the phosphorus in a quantifiable form. The precipitate is subsequently filtered, thoroughly washed to remove residual impurities, and dissolved in sodium hydroxide. The resulting solution is then titrated with nitric acid using phenolphthalein as an indicator, with the endpoint marked by the disappearance of the pink color. Finally, the phosphorus content is calculated based on the recorded titration volumes. To calculate the phosphorus percentage, start by subtracting the sample titer volume from the blank titer volume. Then, divide the resulting value by the weight of the sample taken for analysis. Finally, multiply this result by the factor of the nitric acid used during titration. This method provides a precise determination of the phosphorus content in the sample. So, we have seen many reagents and chemicals are used in this test. Have you ever heard phenolphthalein being used in your school lab? What color change does it show in a titration? Phenolphthalein shows a pink color in basic solutions, and the color disappears when the solution becomes acidic. Sulfur can be estimated with the help of a CS analyzer, which determines sulfur content by combustion in an induction furnace and measuring the resulting gases through infrared absorption. For special castings, the chemical composition can also be determined using spark optical emission spectroscopy. This technique analyzes the samples by creating a spark on its surface and measuring the emitted light, which provides precise and rapid results, ensuring the castings meet required specifications. Workmanship and finish. Clause 7 of IS 210 talks about workmanship and finish of the casting. The quality of workmanship and finish is a cornerstone of the casting process, ensuring the product meets technical, functional, and aesthetic requirements. Heat treatment. Heat treatment is a critical and flexible process used to ensure the performance, durability, and lifespan of castings. It allows manufacturers to meet specific design and functional requirements while improving the overall quality of the product. According to Clause 8 of IS 210, castings are generally supplied without heat treatment. However, if heat treatment is necessary, it should be performed in accordance with IS 13655.
Microstructure analysis is essential for understanding the microstructure and composition of grey cast iron to assess its quality and performance. An understanding of microstructure will help to understand the mechanical properties such as strength, hardness, ductility, and the phases in the product, and also grain sizes wherever applicable. Sample preparation for metallurgical tests include the following steps. Grinding. The sample is grounded using progressively finer abrasive papers on belt grinder. This is followed by manual rubbing on abrasive paper of various grit size. This step removes surface deformations or damage from cutting process and ensures a flat, smooth surface for further preparation. Polishing. Polishing removes scratches from grinding process and produces a mirror-like surface. It is done with increasingly fine diamond paste or polishing cloths to achieve a smooth finish on double disc grinder. Etching involves treating the polished sample with chemical reagent Nitrile solution to reveal the microstructure. Different etching solutions highlight various structural features such as grain boundaries, phases, and inclusions. After preparing the sample, it is positioned on the viewing platform of an inverted metrological microscope. The magnification is adjusted to obtain a clear image of the microstructure. The microscope's built-in camera captures the microstructure image, which is analyzed using specialized software on a desktop. The various phases observed in the microstructures are selected using the software, and the software enables direct calculation of the amounts of ferrite and pearlite present as required by Clause 9 of IS 210. The obtained microstructure is then compared with distribution specified in IS 7754 Part 1 2022 to document the distribution of laminar graphite as required under Clause 9 of IS 210. Now, let's recall what you have learned today. Which chemical reagent is used for etching in grey cast iron analysis to reveal its microstructure? That would be Nitrile solution, which is a mixture of nitric acid and alcohol that's used to etch metals.
Provision of test bars and 13 size of test bars. Grey cast iron being a versatile material, it can be molded into any design and size. However, in the testing laboratory, due to space constraint, test bars of size as mentioned in Clause 13 of IS 210 is supplied for carrying out the test. These test bars are casted at the same time and from the same melt as casting they represent. Frequency of testing. Grey cast iron casting is a continuous process, making it impractical to conduct tests on every production run or at all times. Therefore, the testing frequency is defined as per Table 1 of IS 210, which specifies the number of tests required for each melt or batch of castings.
Tensile strength. Tensile tests are conducted to assess material strength, elasticity, ductility, yield strength, and suitability for applications. They help determine a material's behavior under stress, ensuring it meets quality standards and performance requirements. This information is essential for material selection, design and regulatory compliance. Here's the step-by-step process. Start by preparing a sample from cast iron bar, ensuring it meets dimensional specified in the standard. Secure the sample in the UTM using the appropriate grips, making sure it's tightly fastened. Enter the test parameters into the software, including the gauge length and cross-sectional area. Then initiate the test by starting the machine. As the load increases, the sample will eventually break under stress, and the software will automatically display the tensile strength of the sample.
The requirement of the tensile strength for various grade is as per Table 1 of IS 210.
Now moving to testing parameters.
Which test is mentioned in IS 210 that assesses a material's strength and elasticity? That's the tensile strength mentioned at clause 15 of IS 210. On which machine is tensile strength test conducted? The tensile test conducted on a universal testing machine UTM.
Hardness. The hardness test evaluates a material's resistance to wear, which is essential for quality control. This test ensures that material meets industry standards and are suitable for specific applications. To conduct a hardness test, begin by cutting a flat sample from the cast iron block. Polish the sample to remove any machining marks. Place the sample on the platform of the digital hardness testing machine. Use the software to adjust the magnification for a clear view of the surface. Start the test, and the machine will create an indentation on the sample's surface. The equipment will then measure the dimensions of this mark to calculate the hardness value.
The requirement of the hardness for various grades is mentioned as per Table 1 of IS 210. Which test is mentioned in IS 210 that assesses a material's resistance to wear? That's the hardness test mentioned in clause 16 of IS 210. On which machine is hardness test conducted? Hardness test is conducted on Vickers hardness machine.